Hi there. My name's Scott Johnson. I'm a dad, and this is the very first episode of Dad on Rails. My son is an aspiring web developer, and in the age of COVID, it is hard for him to find other people to learn from, so I am stepping up and teaching. And that's okay, because I love to teach. So, let me tell you who I am and a little bit of my credentials, and then you can decide whether or not this is worth listening to and watching, or you can nope the hell out and go find something that is far more interesting on YouTube. All right. I'm a full-time web developer, software engineer. I have been doing this stuff since forever. I've been shipping software since 1987. I've been doing stuff on the internet since 93-ish. I was at the first technical conference where Tim Berners-Lee unveiled the web. I have written a whole bunch of web stuff over the years, most notably Feedster, which was a blog search engine back in 2003 to 2006, before my board fired me. I have written App Data, which was a web analytics site about mobile apps. And most recently, I'm responsible for covidnearme.org with a co-founder. Covidnearme.org is a website which helps you understand what's going on with COVID with respect to where you are, i.e. the near me is pretty important. Okay. So, my son is an entry-level web developer, and I thought this first episode would be about something near and dear to my heart, which is databases. I stinking love databases. Okay? So let's start with what a database is. A database is a software tool which organizes information and makes it accessible in some fashion. Okay? And that definition, if you notice, didn't say anything about SQL, didn't say anything about NoSQL, didn't say anything about third normal form, etc. Because a database at its heart is just a way to get into a collection of information and access it in some kind of fashion. Now, the type of database that we all mostly think about is generally what's called a SQL database. SQL, or SQL, is an approach to managing data that was originated by IBM in the late 1970s by a guy named Cod and a guy named Date. Okay, they get most of the credit. And the thing that is distinctive about a SQL database is A, how the data is organized, and B, how the data is queried. Okay. So let's think about a web application. And let's think specifically about a canonical application, such as the ability to log in and log out. This information is usually stored in what's called a users table. Okay? So the first lesson here is that tables, and some people will differ, but I firmly believe that tables are named in a pluralized fashion. So you don't have a user table, you have a users table. If you had a table that stored products, it would be called products, not product. Okay? People have different opinions on this one. I have found that the practice of naming things plural makes your queries very understandable. All right, so what do we know so far? We know that we have a database. We know it's called a SQL database. We don't know what SQL means yet. And we know that tables are named in a plural fashion. Okay? So we return to our users example, which is and this table is going to support login. And so let's basically say that we have basically 3 columns on this table. 3. The first column is what's going to be called an ID column. And this guarantees that the information in the table is unique. Okay? Or excuse me, this guarantees that the row of data where the information is stored is unique, because IDs are usually what are called auto-incrementing integers. They don't have to be auto-incrementing integers. They could be timestamps, they could be anything else, but usually the purpose of an ID column is to ensure uniqueness. Okay, The next column is going to be email, because this is going to be how we're going to log into the user to the system. And the third table is going to be password. Okay. Now, that table, ID, email, password, that's a map for how you're going to put data in there, right? Those are the columns. And that data is going to be what's called typed. So an ID is going to be an integer. That email field, that's going to be a string, and it could be one of two types generally in a relational database. And the other way to name a SQL database is called a relational database. And I'll try and remember to explain why we call it relational in a bit. So your email field is going to be what's called a char or a varchar. Okay? Normally speaking, these days, 2020 era, you don't tend to worry so much about lengths of strings. You just tend to stuff stuff into the database as what's called varchars. Okay? And varchars usually are expandable length up to 256 characters, or 255, depending on where you start. Okay. So now we're going to talk about why it's called relational. Let's say we have another table, and let's call it products. So we're building a database where users can log in and then they can add products to the system. So our products table might have 3 columns. Again, 3. Look at that. So the first column would again be called ID, and that would again be our auto-incrementing integer. The next column would be called name, and this would be the name of the product. And the third column would be called user_ID. And this column would allow us to know what user added the product to the table. And remember when I said I'd come back and tell you why it was called relational? This is why. A relational database is a series of tables whereby there can be relationships amongst them. So we create a users table and we log it, we add a bunch of users. Okay? The first user will be user ID 1. That user will then go into our system and immediately add a product, and that product will be called foo, because everything in computers always comes back to foo. And then when that user is stored, when that product is stored, the value of the user ID, okay, i.e. 1, will be stored in that products table, and that will tell us that user number 1 created product foo. And that relational is what gives us, is why we call them relational databases. That relation. Okay. So I've used the term SQL or SQL. And what does that mean? That means structured query language. So when you get information out of a database, you do it, if it's a relational database, through a query, and that query is actually written in a language. And this language is called SQL, and it is what is known as a declarative programming language. Okay? So let's say, for example, I wanted to get back all users from the database that had the email address scott@bar.com. That query would be written as in this way: select space star space from space users space where space email space equals space quote, and this would usually be a single quote, although it could be a double quote, scott@bar.com, end quote, semicolon. Okay? Semicolon may or may not be optional. Select star from users where email equal value. And that is a SQL query. Okay? Now, that is roughly one of the simplest SQL queries that you can write. Okay? But one of the nice things about it is it expresses the power of SQL. by being a language, you are able to do things with SQL that you are not able to do without a language. Okay, and I know this seems rather abstract right now. Very first time, probably maybe your first query. What I would ask for is a small degree of trust. After all, you're watching me drive around in a car and like record crap about web stuff. So give me a little trust here. Queries, languages are very, very powerful. Okay? All right now. Okay. So we talked about tables. Okay? Tables are the things that organize our data. We talked about relations. Relations join information across tables. We talked about queries. And now let's talk about a couple of other things. Yes, and that is me filling space while I frantically try and remember what I'm supposed to talk about. Because honest to God, I am freewheeling this as I go on a car ride because COVID has shut down the world, and why not drive even if you can't get out of the car at the other end? Okay. There is a principle in databases that everything should be stored once and only once. And this is what is usually referred to as normalization. Okay? So in other words, when you store something, if you store it more than once, at some point you're going to need to update it. And that update is then going to have to be executed twice. And not only are you likely to not do that correctly, you are likely to have a problem in your code. So first rule of thumb is store things only once. Okay, that's normalization. And of course, there's an exception to this, except when you have to store it multiple times, usually for performance. So there's a process when you build a database called database design, where you normalize your data and then you deliberately denormalize for performance. Okay, and I'm just planting a seed here that I will come back to either in this video lecture or in another video lecture. And I will clarify that. All right. So we talked about that table, and we said that we wanted to ensure uniqueness on our table. So we have a table, and a table consists of multiple rows. Okay. Each row would store a user, and that user would have an ID, an email address, and a password. Okay. So the first thing to understand is that putting stuff in a database does not actually make fetching the data fast. Fetching the data fast only happens through what is called an index. An index is where you tell the database, hey, this information is important. I need to be able to look for it quickly. Okay? And so just putting stuff in a database doesn't make it fast. That's a mistake a lot of people who first use databases do. They think, oh, I'll put it in a database and I can search for it. Yes, you can, but only slowly. So when you create a table, you add an index. Okay? That index is on one or more fields or columns, right? Each of those things we're putting into the table is called a column or a field. And in this database, what would we want to access? What would we want to have indexed? We would want an index on our ID column. You always put an index on your ID column because it helps ensure uniqueness. And then the other column we would want to index is going to be the email address. And the reason is that when you build a database, you need to think about what's called the access pattern of the data. Okay? And when you have a users table, you will access this in one of, generally speaking, two ways. I want to look a user up by their ID number, or I want to look a user up by their email address. Okay? No one ever looks a user up by their password. And since those are the only three fields here, okay, and yes, if you've ever designed a users table, I know this is a contrived example with minimal fields. This is learning, people. Okay. Now, So you'd have an index on the users table, and that index would have what's called a constraint on it, and specifically it would be called a unique index. And the reason for this is that you want to only allow one user into the system with the same email address. Okay? And if we were organizing our database by username instead of email, we would have the same constraint. So basically you'd have a unique, the syntax for this would be something like create unique index on users, parentheses, email. Okay? And that's not 100% right, I suspect, because I don't have a reference book in front of me, I don't have a code in front of me, and I don't have a code example in front of me, and, well, honestly, I'm driving, people. All right. So now, let's go back to that products table, and would we have an index there? And the answer is yes. We'd have an index on name, and then we'd also have another index on user ID. Why? Because we're going to want to be able to build a construct, probably a web page or maybe a mobile app, that showed what products a given user had created. Okay? Now, can you access information in a database without an index? The answer is, of course. Can you do it fast? The answer is yes, both yes and no. When you have a lot of anything, you need an index. When you don't have a lot of anything, you might be all right. Okay? All right. So let's review. A database is a collection of information. Okay? Databases are composed of tables. Tables are named in a plural fashion. Each element within a table is called a row. Rows are broken up into multiple columns. And we use indexes to make retrieval fast. Now, the next thing is, can we retrieve information across multiple tables? And the answer is yes, and this is done with what's called a join. Okay? And this is the idea where, let's say, for example, you wanted to build a list which had the products that a user created and the email address of the user that did that. Again, two tables: product, which has ID, name, and user ID, and users, which has ID, email, and password. Okay, so here is what that query would look like. Select products.name, comma, users.email from products, comma, users, where products.userid equal users.userid. That's it. So yes, you can actually create a query that spans tables. All right. Next question is, can I order my query, the results of my queries, or they just come back higgledy-piggledy in some kind of random order? And the answer is, of course you can order them. And this is done by adding what's called a clause to our query, right? And if you remember when you took when you learned how to speak English, remember that section when the English teacher was at the front of the room and they sort of nattered out about clauses? Clauses are still a thing. All right. So let's say we wanted to get a list of our users and we wanted to order them by their email address. Select space star from users, order by email. That's it. Okay? Now, we are 19 minutes into this. I don't think this is bad for an overall introduction to SQL and relational databases. We're going to talk about a couple other things, and then we're going to call it a wrap. All right, and I really hope the background noise is not too terrible in this. I apologize if it is. Okay, so we have talked about relational databases. And these are near and dear to my heart because I am a relational database programmer, and I actually do that really well. And I'm not boasting, I've been doing it for a ton of years. Okay, just get over. All right. So, are there other types of databases in the world? Oh my heavens, yes. Databases, okay, the first thing to understand is there is a lot of data in the world. And not all data is well stored in a relational database. Relational databases have unique characteristics, as does everything else in the universe. This cup has unique characteristics. It is good at a certain thing and bad at other things. Okay? Databases are the same damn way. All right. So a relational database in particular is good at storing information that has structure. It is good at storing information in a way that it can be explored via a language. And it is good at storing information where there tends to be lots of attributes and relationships. A payroll system is one such example. A payroll system would have tables like the employee, another table like the times they worked, and then a pay rates table, and so on. Okay. Now, there are other types of databases, and then there are things that bridge the gap between databases and other technologies. So let's give another example. There are what are called NoSQL databases, and these are databases that, ta-da, do not use SQL, okay? And that is their claim to fame. And these are also often referred to as what are called document-structured databases. So in these databases, an example of which is MongoDB, okay? Or CouchDB, or Cassandra is also another document database. You store data as a structure, which is usually these days encoded in a standard called JSON, or JavaScript Object Notation. And how to use these databases is outside the scope of this. The reason why I started with SQL databases is the bulk of the world's data is stored in SQL databases, and they're fast, they're strong, and the data in it is what's called durable, i.e., it tends to not go away very easily. Okay? And because data is really, really important, and when I say that, when you build any kind of a system, the underlying assumption is that the code that you're building may get thrown away, but the data will live far, far longer. Okay? So your data is valuable, and so you should store it in such a way that it will last and that you can change it and alter it and grow with it. Okay? All right. That is probably a good essay on databases, and I will be back because I have a son that needs to learn, and hopefully this is helping someone besides him. Thank you very much.